Progress, improvement, human advancement. No matter what you call it, and no matter what form it takes, it all begins the same way, with questions, bold questions, audacious questions. Questions that inevitably lead to more questions. And there are few areas of study that have asked more audacious questions than healthcare. What if radiation could help us see inside the human body? What if we could fight bacteria with mold? What if we could harvest cells to fight cancer? To arrive at innovation, we need to be willing to be brave. Brave enough to say, we don't know, and then searching until we do. At Smith+Nephew, we are no stranger to questions like these. For more than a century and a half, we've pushed ourselves to shape a new future in wound care. Together, we have moved from impossible to it's possible. It's possible to prevent the burden of surgical site complications. It's possible to simplify negative pressure wound therapy. It's possible to reduce wound care practice variation. It's possible to create a pathway to healing. It's possible to release time, waste less, and improve lives. Through our pioneering spirit, we are shaping better outcomes. We are shaping healing time. And one audacious question at a time, we are shaping what's possible in wound care.
Good afternoon, everyone, and welcome to Shaping What's Possible in Negative Pressure Wound Therapy on the Edge of Innovation. My name is Amy Casson, and I'm with Smith+Nephew Canada, and it is with great pleasure that I get to introduce today's speakers to you. Nico Conti is the Senior Global Marketing Manager for RENASYS brand, and he's come all the way from Milan, Italy. And Chris Webb is the R&D Product Development Design Lead, RENASYS brand, all the way from Hull, UK. But before I turn things over to our speakers, I have two housekeeping issues or announcements to make. First is that there are two polling questions in this presentation, so please get your VFairs app out and ready to use. And secondly, we will be taking questions at the end of this session. So for the people in the room, you have the two mics that are set up. And then for the people online, you can enter your questions in the chat. So without further ado, I will turn things over to Nico and Chris.
All right. Good afternoon, everyone. Thanks, Amy, for the nice introduction. So welcome to our Smith+Nephew Symposium. So what are we going to do today? You see the agenda is here. We're going to go through three main and quick steps. So the first one, we're gonna tell you a little bit about our history. You probably have seen in the video earlier that from when we start back in the World War I, driving innovation in wound care. Then I will hand over to Chris, who is taking us through the process, like from how we basically listen the feedback, collect feedback, and then create our product to address those unmet needs. And then last but not least, I will take you through a few features about our newest innovation in the negative pressure space. So, continuous innovation and product development. So, as you see, as a Smith+Nephew, we've been dealing with negative pressure since 2007, so they are not quite new in the space. And probably every other year, more or less, we have brought something innovative into the market. So we started back with our old school analog negative pressure device, our Easy Max. Then in 2011, we launched the first ever single-use negative pressure, our Pico. And then we kept going. 2013, we launched our main differentiator, which is the soft port. So for the first time, we have got like a soft tubing into the traditional negative pressure place, and all the way to 2023. The reason why we're here today, we're going to introduce and officially launch Edge globally. Canada is the first market that is actually having this product, and more to come. So I'll hand it over now to Chris, that we have learned a lot in this journey. So in these 16 years, you try, you fail, you get again, you improve, you got the good and the bad. The most important thing is that you learn and you take it to the next steps. And how we did that, Chris, over to you.
Thanks, Nico.
What?
Okay, so ideation stage of the product development phase is absolutely crucial. It's all about understanding the voice of the customer. So who is the customer? We have multiple. We have the surgeon, TVN, WOCN. We have a patient, a caregiver, a lay user, a biomedical engineer, a repair technician, an operator of durable medical equipment fleet. All these people have a voice. And so the very first phase of product development that we go through is called voice of customer. We take user interviews. We visit locations where people operate these devices, including the dirty places where they get serviced, to understand, what are the challenges in the current marketplace. And from that, we then use a system called quality function deployment, which is a way of just boiling down a lot of verbal text into some simple bite-sized messages. And we take those user verbatim statements, group them into what's called substitute quality characteristics. This is just an engineering expression for how we as engineers see speech. It's like a thought bubble process. It's like a word map. Yeah. Once we've got those grouped, we then take substitute quality characteristics with similar trends and themes, and we group these into very high level user needs. Okay. So there we go. So this is just some example data from quality characteristics that were grouped, and out of this, we ended up with a series of user needs for different representative groups. So we have the patient, and one of the key characteristics that the patient was interested in was alleviating the burden of living with the wound. So how can we design the device to better manage the patient wound without affecting the patient lifestyle, without disrupting their sleep, without a device that emits bad odor, without artificially triggering alarm conditions that need attention. From the clinician's point, we are looking at how do we alleviate the burden of caring for the wound. So how many times does that clinician need to visit that wound site? How long does that take to prepare the wound, to dress the wound? So what can we do to simplify the whole process of applying the negative pressure and the therapy and maintaining that? And then finally, from the operational point of view, whether that's us at Smith+Nephew or the durable medical equipment provider or the hospital biomedical engineer, how do we streamline the maintenance for a higher utilization? One of the key problems that we encountered when we started studying negative pressure wound therapy application was the very low utilization rate of devices. They were often in transit from one place to another. They were often back for repair. So what can we do to actually improve that sort of overall operational efficiency of the device? So having identified the very high level user needs, and there are really only 4 or 5 user needs for this product. We're keeping them at very high level by this stage. We then move into a definition phase. So the definition phase of the project uses systems engineering techniques. We call it the V model. And down the left side of the V, we have the definition of what do we need to do with this system? How do we explain the system? How do we deconstruct the system from a user need to a design input, and then more low level to a systems requirement that we can give to a software developer or an electronics engineer or a mechanical engineer. So typically in this project, we had around 5 user needs, which deconstructed to around 100 design inputs, which then went down to around 600 individual system requirements. So what would a design input be? It could be to satisfy the patient that we're alleviating the burden of living with the wound. So that could be portability of the device. It could be quietness, discretion. It could be the odor management. It could be that the alarms are appropriate and not false alarming. So those kind of high-level design inputs are testable. Once we've established the design inputs, we then need to go to reviewing the technologies. So we take a look at all of the available technologies that are out there in the interim period since we last designed the product, and we look at how technology's evolved. So more sensors, more radio communications, lower powered devices, better active filtration for carbon filtration for odors. And we take those technologies and we try them. We characterize them. We try and understand how they interact with each other, and we iterate the design. We generate patents. We test solutions with human factors, formative studies. If we don't understand how the user is going to interact with a feature, we try it. We bring in lay users and we ask them to give us feedback on how that particular solution works for them. And then finally, we get to the verification phase. So what we're trying to do here is verify that the system design inputs have been met and that we can test them all and they perform against the acceptance criteria. So in this phase, we're looking at using wound models, and we're doing compliance testing. We're looking at safety testing as well for the product to meet safety standards, which then proves that we've met the design input specifications, and we then validate against the user needs. So we conduct a human factors summative to make sure that the device in the real scenario is truly usable and delivers the user need. So it's a cycle of deconstructing and reconstructing to actually achieve a product that's marketable and ready for launch. Finally, we get to regulatory submissions with Health Canada, with FDA, with CE marking. So this gives us permission to actually place product on market. Okay. So just a few stories and a few interesting facts around the development process. So the RENASYS EDGE product has taken us around 4 years to develop. We weren't initially expecting it to take that long, and that's mainly because of one global pandemic, which we didn't see coming.
It didn't really help, right?
Yeah. That was a total blindside to us. However, we didn't waste our time during the global pandemic. What we actually did was we stopped working on RENASYS EDGE, and design team picked up tools and started to work on the ventilator challenge that was set out by the British government, because they foresaw that we would need a vast quantity of ventilator units, and we didn't have them. So within 5 months, we had designed, tested, and had approval for a mass-produced ventilator. We had a manufacturing site set up and ready to go. And the night before we were due to go live, the government changed its mind and said, you know what, guys, we think we need a different ventilator. We specified it wrong. So, yeah, so that was a lot of sleepless nights for a lot of people, but we did get a nice letter from the government thanking us very much for our effort. I think there were 2 companies that actually succeeded to get a viable ventilator manufactured and approved, and Smith+Nephew is one of them. So we're proud of ourselves for that, at least.
So it's not only about wound care.
Yeah. So, as I mentioned, there's a lot of testing required to validate the product. And one of the things I was going through some of the test reports to try and figure out is, can I quantify how much? I came to the conclusion that we had done in the region of 20,000 hours of wound model testing. So this is to test all of the limits of the performance envelope of the product. So we operate with different filler materials, different wound sizes, different pressure settings, different exudate viscosities, different levels of airflow. What else? Elevated wounds.
And just name it.
Everything. And so it's a very, very time-consuming process because there's nothing like doing it in real time. And so it's just a very long and slow process. So this is formal testing. Informal testing prior to design verification, we may have done 2 or 3 times the quantity of testing. So I'm kind of guessing, but I'm thinking maybe 30, 40,000 hours more behind the official testing that we did. So just as an idea for how much goes into a product that you don't naturally get to see as a user of that product. So who did the work? Obviously Smith+Nephew did, but we can't do all of these things on our own. We have a relatively small design team, highly skilled, but we need to flex that design team to get these kind of projects finished. So we use contract partners, where we're using design partners for mechanical and electrical components. We're using human factors partners for doing the formative and summative studies. We're using injection moldings specialists because that's something that's not really our core. We're using a lot more consultancy like radio frequency engineers because sensors embedded in products are incredibly complex things to design. So this is new technology to us. And the partners that we have are probably some of the best globally. We have contract manufacturers from Malaysia who are located actually in Scotland in the UK, which is very beneficial for us when we're in lockdown conditions because we could get there. So having a local supplier really benefited the ability to pivot quickly and get designs tested, validated, and it really enabled a collaborative approach to the product development. We're also using US partners for manufacturing the canister. The canister that we use on the product actually comes from Harmac across the river. So apologies for that. They're in Buffalo, New York. Yeah. So we have a global team of engineers that are behind this. It's not just me, the people in our organization. We've got a rich talent of designers and engineers that have enabled this product to come to life. So it's been a privilege to be on the project. I'm pleased to see it launch. It's been a relief, and I'm proud to present it to you. And I hand back over to Nico.
Right, thanks, Chris.
Yeah.
So this is basically what happened when I go to Chris. Say, Chris, I need a new product that is like patient friendly. I mean, it's good for clinician, and it doesn't need any maintenance. So it's like for me, it's like okay, these are my input, but you see the amount of investment, time, work, resources that we put in place in order to actually develop a physical new disruptive product. But then does it stop there? Well, sort of like no, because yeah, okay, Nico, this is your product, fine. Okay, what's the next step then? So I'll take it to the most important people around the globe and gaining and validating what they've been thinking and doing for the last 4 years. So what we did, being Canada, the first one globally that is going to get RENASYS EDGE, we came last year, around, it was like June time, I believe. So we did the first innovation tour, and it was done across pretty condensed time. It was super nice for me. It's the first time that was flying here, 5 different city, 4 days, 5 days, 4 different city, 10 events all across, and 30 plus clinician involved. And the feedback that we got, I mean, the feeling that you have when you're creating, and then when you actually get the positive feedback behind that is that this is something that you are doing the right thing. It's sort of even difficult to explain, that you're really doing the right thing. So what was some findings that I would like to share is well, we heard that Staff turnover was a kind of a big challenge, especially when it comes to traditional negative pressure, that you need to keep training. So, the more complex the device, the more time you need to spend on training. And then, you got a different people, different turnover, you need to start and again. Okay, yeah, let's keep that in mind. Then we have negative pressure as a therapy is complex by itself. So you need skilled and experienced people to drive it there. So how many skilled people do we have, and how can we actually empower them to cascade their know-how to less experienced people, so you can actually have more patients that can be put on therapy as early as possible, or like the possible. Last but not least, we are looking for a different value, different sort of something disruptive, something new. Say, okay, that sounds good. And then say, so what do you think is that? So we thought about something that drives simplicity, like easy to use. I would do something that will be well accepted. Well, that's yes. Something that doesn't need any maintenance at all. So the moment that you have the device is with you, it stays with you, doesn't have to come back to do any maintenance. It was that's interesting. It's probably the first time I've seen that. A small, well, you can see that it's quite small, compact, but yet can be used in both a hospital, long-term care facility, as a home care. So we can try to deliver continuity of care across the different settings. And then it's also not only about the pump, but it's also, we did something that we're going to show you in a second about putting technology into canisters as well. That will help, and smooth the whole process. Time for the first poll question, which is approximately how often do you use traditional negative pressure in your practice? Never use it, once a year. So it's a good mix that we have, that hopefully, once a week, which is kind of good frequency, once a month. It's also, I appreciate it, depend upon the different setting, different patient that we have. So why I'm asking that is because we thought that, and this is proving that every setting is different. Every clinician needs are different. So we're trying to do what? We're trying to address all the different needs. And if somebody never use it, well, let's try to make it as simple, as intuitive, even if somebody never use it, can deal with that. Is somebody using it on a weekly basis? Well, if we can make it easier, that have extra time to actually teach other people like how to use it and empower them, even better. You grow your team as well. So without further ado, I'll move to the next line, and it's my pleasure to present the new RENASYS EDGE. So this is it. This is RENASYS EDGE. It's not only about the pump. As you can see here, is the system itself who makes a difference. So we got a pump, we got a canister inside, which is hidden, and I'll tell you why we thought about doing that very specifically. And it's also about how we get to the wound. So again, our soft port is something that, as part of the system, makes a massive difference, being soft. So it removes, like, sometimes based on the different wound location, the need of bridging, being soft, so patient can lay on top of that without being worried of developing medical device related pressure injuries and so forth. So again, yes, it's the pump, yes, it's the canister, but it's the whole system that really is going to make a difference in driving innovation. So remember what Chris said, like we identified the main need for the patient from a clinician as well as from an operational standpoint. Well, when it comes to patient, we designed it like it's lightweight, it's compact, like it's self-standing, you can carry around quite easily. You see it has a minimal impact on patients' life. And this is actually the main thing. You know, those patients that have to live with a pump, they have no choice. So let's try to make it less disruptive as possible, because anyway they're already scared that they have to deal with a pump or something they are not familiar with. So let's think about that and address that. So how we did it, as I said, in the canister, we call it discrete canister because it actually goes inside the pump. So from the front, you won't really see the exudate all the time. But from a clinician standpoint, I want to see the exudate, but you can see that from the back of the device where you got a transparent window that you can see the level of the exudate. Whether it's on the 300 ml canister, on the 800 ml canister, you always be able to see that quite easily and immediately. Then we said, fine, so that's more for the patient, but how about clinicians? And again, as I said, we wanted to drive simplicity, keep it simple. So how we did that? So we want a device that, even if I'm not telling you how to use it, is that intuitive that, you figure it out by yourself how to set it up. So you have very clear user interfaces, and which really will make your life super easy and fast. It's not only about that. So what is everything goes all right, fine, happy days. But what happens if there is some alarm, some issues are happening on the pump that they need troubleshooting? So we invented those tutorials, animated tutorials on board that will basically take you step by step through the troubleshooting process, whether it's like a leakage alarm, or the canister full, is a blockage alarm, you need to charge the pump will guide you step by step. And this is what I mean by, keep it simple and simplify negative pressure. Let me give you an example. So when you have a leakage alarm, the pump automatically will bring the alarm screen on, and they'll ask you, click this button to get help. And then you see like step one, say follow the different step. So this is a live flow meter, right? So our objective is to bring that one down to the green part. And say, okay, what do we do? And think about not experienced nurse or nurses that you need to train. First thing, you see, check the canisters. The second one would be check if the connector is actually connected correctly. For at last, and again, you see the animation that you will see on the pump, is like check the drape. And by the time you're checking the drape, you're trying to identify where the leak is, the flow meter will just go back to the green position, and then will give you a clear signal that, leak resolved, therapy is going on. Then we have the last part, which is like we wanted to drive efficiency from an operational standpoint as well. So Chris' idea was actually implementing what? Implementing something that we call self-test on the pump. And it's simply, a process that takes what, 30, 45, 40 seconds,
25.
Where basically the pump checks every single functionality, whether it's like the different buttons externally or the pump internally. And after you do that, you basically have the pump ready and validated for the next patient. So you clean it, you restore the default setting, so you delete the patient data, and it's ready to go. So the whole process takes less than 5 minutes. And this is why we said the pump doesn't need any preventive maintenance, because you're basically doing a mini maintenance, sort of speaking, every other patient. So it gives you like even the confidence, like is working fine before moving into the next step. Now, as I said, it's only about the pump. Well, it's a lot about the pump and what we implemented in terms of disrupting and new technologies. But it's not only about that. It's also about what we change in the canisters. And for that, Chris, I'll hand over to you so you can take you through.
Thank you. One of the canister construction historically has been suboptimal from a few different perspectives, because the O-ring that interfaces between the canister and the device used to be on the device side. So what we did was we realized that if we keep it on the device side, we have to maintain it. So we have to send the device somewhere. Someone has to change this thing over. So we actually switched the location of the O-ring seal, and that's now part of the disposable canister. So every time you change the canister, effectively, you don't realize it, but you are doing some kind of maintenance that was previously necessary on the older version of the product. We have a dust filter, which is there primarily just to prevent carbon particles from the high-performance odor filter from being sucked out and into the pump. That's just a preventive measure. The high-performance odor filter is quite an interesting component of the pump. It's made of a coconut carbon. So the thing about the coconut carbon is the particle size is very, very easy to control and has a very high porosity. So if you're looking for a material that can really give you a high surface area for odor removal and is particularly good at removing volatile organic compounds, then that's your material, really. So we've worked with a carbon block technology company in the US to really refine this process for our needs. When we tested this in laboratory conditions, we used an array of foul-smelling chemicals. Excuse me while you're eating lunch. However, the good news was that the detection level beyond the filter was actually below the detection threshold of the equipment. So, hey, that's a good thing. So what goes in doesn't come out, and again, that kind of plays into the lower requirement for servicing the product, because previously a lot of pumps would come back with bad smell, and that was the reason that they were returned to us. So if we can prevent that from happening in the first place, an ounce of prevention is worth a pound of cure. Then finally, the lowest element of the canister filtration system is the bacterial barrier. So we're using oleophobic materials here. We originally used hydrophobic, but realized that oleophobic is better suited to fats and the kind of materials that you're going to find in a wound fluid. So the nice thing about oleophobic materials is if the canister is inverted for any reason, the filter will temporarily block, the alarm will sound, and it will teach you to restore the canister to the upright position. Once you've done that, the filter simply sheds those fluids off, and you get back to a normal airflow condition. So it's kind of self-recovering, which is a nice feature. And then finally, we have this NFC sensor. So NFC is near field communications. We all have it on our phones, on our Apple Watches when we tap to pay for things. That's what it's using. And it's a very short range of communication. So these sensors are used commonly in supermarket product tags, and they actually have a tamper detection bit. So what we've done is we've repurposed the tamper detection bit to allow us to sense the fluid level in the canister. And when the fluid short circuits across the tamper tag, then the canister sensor transmits to the device and alerts the user that the canister is nearly full. So it's a direct measurement for canister full sensing, which we're very happy with. Nico?
Yeah, I probably also tell you that was the first time you're using that canister as well, right? It gives you the canister ID and everything.
Yes,
well, so.
yes, it does. Yeah.
Right. Thanks, Chris. So I think for me, it's the first time I see like a canister which has a built-in odor filter. That basically every time you're doing a dressing change, you're actually adding a brand new odor filter within the canister. So we really try to drive this like smelly wounds and try to not seeing the impact of those wounds on the patient daily living. Time for poll question number 2. on a scale of 1 to 5, where 1 is the lowest and 5 is very confident, how confident are you delivering traditional negative pressure to your patients today? Okay, that's good. That's good. Got some expert 4.3. It's nice changing, which is a great result. So it means that you're really confident. So being confident, we can again trying to help and teach other people and expanding the possibility of giving negative pressure to as many patients as possible. So moving to the next slide, and I would just like pause for a second and try to summarize what I've been seeing so far. So again, we identified 3 main input or user need that we wanted to address with RENASYS EDGE. So the first one we said what? It was the patient. From a patient standpoint, I mean, those patients, they have to live with the wound. So how do we address that? We have a pump that actually been designed for patient. Again, lightweight, portable, discreet, that you can carry around, so no disruption. But then at the same time, we had somebody who actually have to care for that wound. So how do we address that? Fine. So a happy patient because they got a kind new cool pump, easy, but happy clinician because for them they're super busy doing a lot of things, even more and more and more. So driving simplicity and like simplify as much as possible, starting the therapy, making the dressing change, achieve the sealing, teaching my colleagues that probably if I'm not going to be there because I have other stuff more important to do, they can rely and teaching on other people. Well, we believe that we addressed that quite well as well. Last but not least, on operational standpoint, so you probably now need less. So you actually optimize the way you're using the pump. And how we did that as, again, self-test within the pump. So you're checking it at every patient. And then basically what we will be doing as a maintenance, we'll change the O-ring and the odor filter every year. Now you're doing it yourself, basically, when you're changing the canister. So you're driving even better pumps performance for the patient. They say, fine. So it looks like we are doing the right thing. Then we launch it. We had when our first patient actually being treated with RENASYS EDGE in Nova Scotia, and say, okay, can you share with us like your fees? What was it like? How did you feel? How did it go? Like, can you really prove ultimately that we did the right thing? So let's listen to him.
My name is Bernard Thomas. I'm 44 years old. I have spina bifida. I moved into this facility a year and a half ago because I was unable to look after myself anymore. I got the wound from compression bandages. They were too tight and they caused a pressure sore on my heel. And it's on the bottom of my foot near my ankle. It's been very difficult. The wound started small and then it started to grow. Nothing would heal it.
Until we found the RENASYS EDGE.
And that quickly helped.
When it first was applied, the RENASYS EDGE felt comfortable.
And I could actually put my foot down without worrying about putting pressure on it. I could sleep well with it because it was so quiet and I didn't have to worry about putting any pressure on my foot while I was sleeping. I was not hindered by it at all. I was able to go out on outings. I was able to play games. I was actually able to do a lot of day-to-day activities. My experience has been a very positive one. It's been very easy to use It's been healing very well and a lot less healing time. It makes me feel great because I can hide it so well and all they see is the tubing.
The transition from RENASYS to PICO was easy. RENASYS EDGE had done its job.
I was able to go to PICO and finish the healing process. I hope other people can benefit like I did.
So after 4 years of trying, developing, and making sure that we're doing the right thing, having this sort of feedback immediately from the patient that actually live with the pump and he managed to heal, it's something that it's like you cannot explain. It's like something like, you know, really make us proud of what we're basically doing on every day. So when you say like, is this possible? Yeah, simplify negative pressure is now really possible with RENASYS EDGE. And with that, thank you so much. It's been a pleasure, and opening for any questions.
Just a quick question. Do you have to charge it? I noticed it said battery. What's the
Yeah, you
charging
can.
part?
Yes.
And how long would it?
Yeah, thanks.
Yeah.
Very good question. Thanks. So yes, definitely you can charge it, and on a fully charged, it lasts more than 24 hours.
So it's got a very
It takes
robust battery.
less than, it's like 2.5 to 3 hours depending upon but to get the full charge when it's like completely off, and then after it's fully charged, you can go more than 24 hours or continuous therapy with no issues at all. So again, thinking about patient disruption, they can actually free going everywhere.
And just my last question on that, mention when you said patient disruption, is there a way of looking back at the history for the patient?
Yeah, so you can access, you want me to take it? So you can action the logs at any point in time on the device.
Right.
So you have basically 2 different logs. You get to know how many hours of therapy per day that was actually on. So you get an average of the weekly. And then if you go a level deeper, you actually see time and date when it started, post, change the canister, which canister was actually applied. It was an alert, an alarm. Is everything tracked on the pump?
Super.
Yeah.
Thank you so much.
Thank you. Thank you.
Can you speak more to the other pieces?
The soft port.
Yeah, not necessarily the tubing and the dressing. Can you speak to those pieces, please? Describe them a bit more.
The soft port
Yep.
port tubing. So
Yep, thank
this
you.
is something that we launched back in 2013, and the reason why we thought so is because the feedback at that time, we hear that, you know, hard tubing is difficult to deal with, especially when we have, well, I'm not a clinician, but hopefully you will agree with that when you got bedridden patient, then, you know, have a lot of tubing. I mean, at least the one that is related to Smith+Nephew negative pressure, it doesn't really cause any pressure point that could potentially develop a pressure injury. So it's patent technology, and I mean, hopefully you have a chance to see and touch and feel it, because it's really soft, but it's made in the way that even if you compress it, we'll make sure that we still deliver the needed negative pressure to the wound. So even when you're doing your dressing, as it's like a very standard procedure of doing the dressing, it doesn't really matter if it's a gauze or foam. You actually apply it, and then you don't really bother whether you need to bridge, because, you know, the wound is on an awkward or difficult or on a pressure point, so you don't want your port sitting there all the time. So the patient has actually mentioned something that for me was like very nice to hear, that he could sleep without, you know, he's got the ulcers on the foot, right? And he said, I could sleep without bothering that, you know, I had actually a tubing all the way applied. And that means that we're doing we hit what we wanted to do. I don't know if that answered the the question. Yeah. Okay. So so what are the kits that can be used? So we got black foam, different sizes, goes, and every kit comes with a soft port already in, and we got the abdominal kit as well. So despite the dimension of the pump, you can be sure that you can use it of any basically indication that you are dealing with on the current practice, whether it's again in the hospital setting or long care facility or as a home care.
And sorry.
Okay, yeah, Amy is definitely closer to me, so she was saying that we are about to launch white foam as well within this year. Yes, Amy, within this year.
And Nico, I'm gonna just clarify so everybody understands.
Yes.
The foam kits that we currently have will be the same foam kits. So the connectors to the canister haven't changed. So it won't be a massive changeover in the knowledge that you have right now. It's the same type of kits. And then there's also the gauze as well, which is the same. The new addition would be the foam, and then the other new addition is the canisters. So the canisters obviously will have a different SKU number, but that would be it.
Yeah, thanks for clarifying. Yeah, sure.
So we've got a couple of questions online. How frequently do you change the dressing? Do you know those?
Want me to take? Oh,
Yeah.
sorry, didn't hear though. So how often you do the? Well,
How frequently?
so it's not linked to the pump. It's based on the extraction for user and the clinical practice that you have. So as you actually follow the extraction that you are using currently with our foam, black foam or gauze kit. So it's nothing really. So the pump, so RENASYS EDGE won't really change your daily practice from that perspective in terms of frequency. We're trying to make it easier and simpler because you still have to do it. So let's do it in a better way, hopefully.
There's another one. What would be the cost for a unit?
That's probably, Amy, I need your help here, but it probably is something that
Anywhere between 4,000 to about 5,000, 5,500, 6,000, somewhere in that range. So it's a lot more economical than what you're used to paying for a pump.
I have a question. Sorry.
Oh yeah, sure.
Thanks. Thank you for sharing your research and development. In BC, we're looking into reduction of carbon footprint for medical devices and whatnot. So, and as we know, medicine and wound care products and wound care byproducts does have quite a bit of carbon footprint. What is your organization's innovation towards?
Nice question. I love that
reducing
topic.
footprint?
Well, thanks for the question. And first thing, if you compare what we're doing now, every pump has to, so in terms of carbon footprint, they have to come back to the service. So this is an extra footprint that we are actually doing or creating because of the need or the technical need of the pump going back and forth. However, if this one can stay for the entire lifetime, which is 5 years of the pump, then it depends upon the contract. But the pump itself, it got a lifespan of 5 years, and you do the trick of the 5 minutes in between patient, then there is no footprint generated anymore in terms of maintaining the pump and moving the pump back and forth for servicing. So this is the first thing that we look at in terms of reducing that as much as possible on the short term. On the medium to long term, we are trying to look as usually at different component, different plastic, try to, as a company, not only for RENASYS EDGE, trying to move in the way that we want to be as sustainable as possible. We only have one more, so we need to take care of it, basically. So yeah, that would be my personal opinion.
The pump itself contains no PVC. We're working to eliminate PVC from canister tubing, but because it's a legacy product that we have to have equivalence against the current canister, then we're waiting to address that on all products across the range. But as far as possible, where the pump is concerned, we've taken PVC completely out of that. Packaging, we've tried to minimize it. The packaging is recyclable. So it's all reprocessable packaging. There's no plastics in there that can't be disposed of locally.
Yeah. It's more like, as I said, it's like shorter what we could have done it, and then we're looking at medium to long term what we can actually improve moving forward.
There's one more question actually online, and it was around the open abdomen kit, which I think you answered already. So none of the kits are changing. They're staying the same. It's just really the canisters that are changing. So we've always had, and we will continue to have, an open abdomen kit for the OR.
No other question. I think we can close it here. Hope you enjoyed the lunch, by the way.
Yeah, it was.
Thanks
you
very
say
much.
I mean, it smells good.
Thank you, everyone.
Thank you.
All right, thanks.